Good morning, good afternoon, and good evening, everyone. So today I'm going to be continuing my Calculus 1 series, and we're going to be doing another problem here. We're still in tangents to circles, so let's just do it. So the problem for today would be, well, again, we're still going through this idea of tangent lines and circles, so let's just do it. Okay. Oh, that's not working. There. So here we have a circle, and the circle has radius 5, centered at the origin. The tangent line to C at a point Q. Where is this? The tangent line to C at a point Q is the line through Q that's perpendicular to the radial line connecting Q to the center. Right. There's a bunch of yapping. Okay. So we're going to use this information to find equations of the tangent lines. So we're actually finding equations of these two guys. Right. So going back, what we know so far from the previous video that we did was the equation of the circle. So again, let's put that tool. So whenever we're doing math problems, we want to make sure that we put the tools that we've discussed that we think is going to be useful to solving the problem. So the first tool that we can think of is the equation of a circle. What's another tool we can think of? The tangent line. Well, it's just a line. It's a straight line. So the tangent line is most likely going to be in the form, I don't know, you guys tell me, y equals mx plus b. There could be other forms to it. We could do something like y equals I think it was x minus x naught plus y naught or something like that, where both for both of these, m is just rise over run y over x. I think it was that, or it was something like y minus y naught x minus x naught, right? It was something like that. Okay, so we're just looking at tools that we can use. So we're not solving the problem yet. We're just looking at tools that we can use to solve the problem. So we know what the equation, so we know the circle is C. So this thing is C. Let's name it C, the circle. It says its radius 5, it's centered at the origin. So we know the equation of this circle. Okay? Let's just write out the equation of a circle. So this whole circle is actually just x squared plus y squared equals radius is 5. So that's 5 squared. That's 25. Right? Now, if you guys don't know how I got this, feel free to refer to the previous video, which was about, well, the equation of a circle. Okay. So we have this, right? Now, the next thing. So now we've gotten this out of the way. It says the tangent line to C at a point Q. So it's actually referring to this line. So when we're problem solving, we want to really read through what in the world we're solving for. So this tangent line to C at a point Q, it's describing that line, is the line through Q that's perpendicular to the radial line connecting Q to the center. So the radial line would be this one that I'm highlighting in red. And what we're going to do here is based on that information, we're going to need to find the equations of the tangent lines at P and Q. So we need to find the equation. of P. We also need to find the equation of Q. Okay. So how do we do that? This is an interesting puzzle. Let's think about it for a second. So let's say, well, let's find Q first, right? Because that's what I think that's what it wants us to do. So here's the trick. We can actually find both of these lines, the equations of their lines. Why is that? Because while we don't, no, actually we do know the slope, and we also know their y-intercept. So we can actually do that. This is pre-calculus, right? So this line right here will just be y equals the slope. So rise over run, that's 4 over 3. That's, oh, oops, that's m, 4 over 3, x. Now my y-intercept would be 0, 0. So we know that works. This is plus a 0. So I then need to write a b. So that's this line. This other line would be, where can I write it? Y equals rise of 3, run of -4. So -3 over 4 x. That's this other line. Okay. Right. So, but this is not what we're being asked for, right? Because these are the equations of the radial lines. We need the equations of the tangent lines. We need this and this. So how do we do that? Well, let's remember that, and it says here, right? These are perpendicular. So meaning both lines form 90 degrees. This line and this line will form 90 degrees. This line and this line will form 90 degrees. Okay, so let's figure it out. Why or how do we find P and Q? Okay, how will we do that? Mm, let's see. What does it mean? What else can we remember when we're looking at a tangent line? So this one I actually haven't remembered in a while. But now that I think about it, I do kind of recall it. This is line equation. We need more tools. When we're looking at the tangent line, what other facts do we know? When we see a tangent line, a fact that we know is that, so let's say the radial line, if radial line has slope m, then we know tangent line perpendicular to radial line has slope -1 over m. In other words, we probably heard the term negative reciprocal, right? So, knowing this fact, let's see the tangent line Q. We can now find the tangent line Q. So we again start off with y. We know our m, or our slope, which would be, let's say, if my m was 4 over 3, because it's 4 over 3 here in this radial line, then what would be by -1 over m? That would be -1 over m. is negative 1 over 4 over 3, negative 3 over 4. Algebra, right? So this is minus 3 over 4x. But here's the issue. We don't know the y-intercept, so we cannot use this form. In fact, we can actually use this form because we know a point on that line. So when we're using these tools for the line equation, we will only use this if we know the y-intercept. We will only use this if we know a point that's not a y-intercept. In fact, actually, we can use this. This one's the better way to use it because even a y-intercept, we could actually use it here. Okay, cool. So let's use that because we do know a point. How do I know? Well, the point is here. We just connected, that would be 3, 4. So my x naught is 3, my y naught is a 4. So again, just fill out the puzzle yourself. X minus x naught is 3. Y naught is 4. That's the line. Now, if you really want to simplify it, then just go through, just solve it. Okay. 9 over 4. I think I can do this. Yeah, 25 over 4. I can do that. Same idea, right? But honestly, I would stick with this. Way easier. And same thing for the tangent line for B. So that would be y. So again, we find the negative reciprocal. So we know that the radial line has this slope, negative 3/4. So the slope of the tangent line would be negative 1 over m, negative 1 over 3/4, 4/3. So 4 over 3 x minus something plus something. Let's figure out this point. This would be negative 4/3. This point. So it's actually minus negative 4. That's the same thing as plus 4 minus 3. Plus 3. Whoops. I almost messed that one up. Plus 3. So I could again simplify this and get the same answer for the tangent line B. X plus, I think this is 16. This would be 9. Oh, that made an arrow. That'd be 25/3. Okay, cool. So I hope that made sense. So now that we've found these, we're done. We're done with the problem. Solved. Problem solved. Yay. Okay, I hope you guys enjoyed this video, and I'll see you all for the next problem.